Hi all, welcome back to track 2. Next talk is attacking XML processing from Nicolas Gregoire. Please welcome him.
Hi all. So I'm Nicolas Gregoire and I will talk about attacking XML processing. A short introduction about myself. I have been working in information security for more than 12 years. And 18 months ago, a customer asked me to audit several applications using XML digital signatures. And I compromised 3 targets. There was 1 client side and 2 server side. And during this engagement, I found this kind of technology fun. And I chose to investigate more. And now I have a very big bunch of XML-related vulnerabilities. You have client-side, WebKit, Adobe Reader, Firefox, server-side with LifeRay or .NET Nuke, and some libraries which are used a lot. And that's what I will speak about. I will first introduce XML technologies. Then I will speak about encapsulation, which is the fact of hiding some interesting data inside XML containers. Then I will present limited denial of service attacks, which are useful in black box mode in order to detect if a specific kind of processing occurs. And the main technical part, which is the exploitation of both XXC and XSLT vulnerabilities. So XML stands for Extensible Markup Language. We will try to define the 3 terms. Markup, it's easier one. It's like HTML. Everything is between angle brackets. And you have some tags. You have some attributes. So here too. So it's very simple. Extensibility is very important. And in order to understand extensibility, we need to understand namespaces. Namespaces are used to define the precise meaning of a tag, and they are usually defined by a URL. So that's a very simple example. We have a HTML document with 2 namespaces. This is the default one, which is the XHTML namespace, and the full one, which is a private namespace with my own URL. And then when a browser will try to interpret this document, only the word will be underscored because the browser has no idea of the meaning of the U tag in this namespace. Okay? So the main use of namespaces is to avoid ambiguities. For example, if you find a font tag, you need to know if it's related to XHTML, to SVG, or to a very specific Oracle configuration file. But there is some more interesting stuff for attackers. You can use some namespaces in order to trigger some very specific features. For example, the first one can be used to call PHP code from XSLT. It could be useful. The second one can be used to create file in the libxslt parser, which is used, for example, in WebKit. So I published last year a vulnerability when you can create file on the client hard drive. And the third one is used in Zlnj to execute Java code from XSLT. The next term is language. In fact, in XML, in a valid XML document, you can find much more than only data. So we have data. You can have XSLT code inside the XML document. It's still valid XML. You can find some grammar in the document type definition and processing instruction, which will instruct the parser to trigger a specific XSLT code, for example, in order to apply it to a XML document. The main point is we need to be careful that we can have much more than data when processing XML document. So that's an example of a complex XML document. On the first line, you have a processing instruction. On the second line, you have a DTD. Then you have some XML data. Then some XSLT code. And the overall goal of this document is to generate some SVG output. You can see the namespaces here. The question is it really useful to create this kind of document? The answer is yes. This document is several interesting things. It's first some XML data with embedded XSLT code. It's also a self-contained dynamic SVG image, and it's a POC for the WebKit vulnerability dropping file on the victim's hard drive. And if we open this document in several browsers, in Firefox, TransformX is the internal name of the XSLT engine. You have a green circle. It seems OK. In Opera, you get the same result. And in Chrome, Chromium, and Safari, and Maxton, you will get a red circle. And you need to check your TMP directory for a file just dropped. XML is used in a lot of technologies. So I already spoke about SVG and XSLT. If you are reading some blogs, you are probably using RSS or AtomFit. Office documents are mostly XML. Web service use a lot of XML technologies, for example, SOAP or XML RPC. And you can even listen music using some XSPF playlists, which are supported by VLC. So there is some XML documents everywhere. And I have some real-life screenshots of application using XML. So that's the Microsoft Link online service. And as usual, you can provide an XML file, which will be parsed by the application. So you can trigger some specific processing server-side. The W3C offers this kind of functionality, which is an XSLT engine available online. You can provide your own URL to XSLT and XML. So it's very dangerous. I didn't check, but you can probably execute Java code server-side using this kind of interface. Chronopost is a French shipping service. And if you are using the professional version of the interface, you have some link. Okay, you have some link like this. And the fun part is that this kind of servlet and these parameters are exactly the same in the sample application provided with Xalan-J. So it could be that Chronopost is using in production over the internet the sample Xalan-J application, which is very vulnerable to a lot of things. I didn't play with it, but you could try. And that's some Google result looking for in URL, XSL URL equal HTTP. The fun part is that you have a lot of technologies. You have ASPX, you have some XQuery, you have some Java servlets, and here you have some PHP code. So it's really cross-platform. Everybody is using XSLT. Even if you are using PHP or ASPX, everything is possible in XML. When auditing some application using XML, we need to ask ourselves a few questions. The first question is, how can we fit some XML document to the application? It's always the same problem in auditing. And if you find a way to submit data, for example, a file upload or a REST interface or anything else, you need to ask, is the data processed by the application? So I have a nice example. If you upload the SVG file to Wikimedia, for example, Wikipedia, there is an automatic conversion to PNG which occurs. So it can be difficult to detect. You just can upload some SVG file, but you need to know that there is some processing done server side automatically. So if there's some processing, you need to find who is doing the processing and where. It's mostly client-side and server-side. In some B2B environments, you can find some gateways which are doing on-the-fly transformations in order to support several versions of the same protocol, for example. And a very basic example is Atom or RSS feeds, which can be read client-side in your browser or in a dedicated software, or server-side, for example, in your Google homepage. And then, once you know where are the processing points, you need to ask some question about their functionalities. So if you can submit some arbitrary data, are processing instruction executed by the application? If you can submit some grammar, are external entity resolved? If yes, you probably have XML external entity vulnerability. And if you can provide some XSLT code, which extensions are available, you can have something like accessing databases or executing Java code. All the demonstrations during the talk are based on Atom feeds. So it's it's false, but it's a simplistic view of Atom feeds. You have a root tag, which is feed, the block title, and for each entry, you have another title. The demo infrastructure is simple. We have 3 server-side applications, one using Perl under Linux and a dedicated library. One using PHP under Linux, and the formatting is done with XSLT, and one under Windows using JSP and XSLT. And the Atom content is provided by some uncontrolled server on the internet. And here is the Docker. So that's a local copy of the Atom feed from the US cert, as you can see here. And if we submit to the Perl application, we have a very simple display. For each entry, we have the size of the entry and its name. And we have exactly the same layout on PHP and in Java. Okay, so everybody is now okay with XML. We will speak about encapsulation. XDP is a file format defined by Adobe. It's a very old file format, and this is a screenshot of its Wikipedia page. The interesting point is that this format can be used as a container for PDF and XFA data, and it can also be used inside a PDF document. So it's easy to see. We can play Russian dolls, XDP with inside a PDF file, inside the XDP file, inside the PDF, and we will try to find some interesting use.
like bypassing antivirus. So it's the MSF cooltype.pdf file is generated by Metasploit. It's very basic. It's a 3-year-old vulnerability. Excuse me. It's detected here 8 out of 9, and here 27 out of 43 antivirus think it's infected. And we'll try to avoid at least some antivirus. That's the patch for Metasploit. It's something like 10 lines long, and it's very simple. You take your PDF, you do some base64 encoding, and you put the result here, and you get a XDP file. And if we submit this XDP file to antivirus, we get 0 out of 9 and 0 out of 43 antivirus solution. So we have a full some percent detection evasion. The fun part is that XDP files are automatically opened by Adobe under Windows. It's a very similar icon. So if you send an email with a XDP attachment and the user double-click on the attachment, you get your malicious PDF open inside Adobe. So now we will try to create some limited resource starvation in order to detect some kind of processing in black box mode. So if we go back to the SVG to PNG conversion by Wikimedia, we may wonder, is DTD processed? And so we will use the billion love attack, which is very well known. It's quite simple. You define your DTD. You define a lol variable, its value is lol, and the lol1 variable, its value is 10 times the lol variable, etc., etc., etc. And in your document, you insert the lol9 variable. So you have something like in-memory extension of the variable. And if we do some quick math, we will get 1 billion of lol string, which is 3 gigabytes, which could be enough to slow down the server and detect that the DTD is effectively processed by the Wikimedia application. Now we want to detect if some XML digital signature application is supporting XSLT. The norms say it should, and the best practice by the W3C say it shouldn't. So we are something similar. You have the XSL number function, which will convert one number to in another format. We will try to convert 1337, and the I format is for Roman numerals. So we get this kind of output. And the interesting thing is that the M is the biggest unit in Roman numerals. So if we ask for bigger values, we will get a lot of M. So we are requesting some very large number here. And we will get 1 gigabyte of M. So it's similar to the previous trick, but you are here detecting XSLT processing and not DTD processing. So I have a few demonstrations. Okay. So that's the billion love attacks. I just use lol6 in order not to crash my computer. So if I submit to the Perl application, it works. I get a 4 megabyte string. In PHP, you have a kind of error message because, excuse me, here, there is entity reference loop which is detected. I didn't have a look to the code. It probably can bypass. It's PHP. It's easy, excuse me. And in JSP, we will get an error because we can, oh no. So it works, it's another demo. It works in JSP2. And here it's XSL number proof of concept. So the Perl application is not using SSLT, so no point in testing. The PHP one, it works. I don't know if you see the scroll bar, it's very small. And if we submit to JSP, we get an error because it can convert values which are greater than 4 thousandths. I don't know why. It's probably in order to avoid this kind of vulnerabilities, but there is no documentation related to this bug or feature. It depends. Okay, and last thing. If I try to open the feed directly in Firefox, it will detect some atom and will propose to subscribe to the feed. And as you can see, we have the extension which occurs. So it's very funny. Lol. Okay. Now, I will now speak about XML external entities, which is probably the most common XML vulnerability. It's very simple. You define a doc type and an entity, which is here ref, and its value is the content of the etc password file. So each time you will use this value in your document, it will be replaced by the content of the etc password file. That's some XXC vulnerabilities published or found since last summer. In bold, it's vulnerabilities I found myself, and in red, it's vulnerabilities in some libraries. So, for example, RESTlet was patched this week, and there is something like 10 or 20 applications using this library, so they are all impacted. And it's enough to speak REST with the application to steal every file you want, including configuration files. In my opinion, the impact is mostly underestimated. That's what is well known about XXC attacks. You can read some ASCII file, text file, or UTF-8. You can hit the internal network. I mean, you can see the network as seen from the parser. And you can, for example, do some banner grabbing or do some blind hit in order to exploit Tomcat internal servers, for example. You have some specific tricks. In Windows environments, you can use the file handler in order to do some pass the hash or stealing NTLM hashes. And under Java, you can list the content of directories, which is very useful if you don't know the setup of the target. And then we have some advanced features. You can read a binary file. It's in PHP. You can access some LDAP internal servers using Perl. And you can execute some arbitrary command in PHP and much more. Everything depends on the context of execution. It depends on the XML parser itself, the operating system, as we just see under Windows you have some specific tricks. The programming language, because most Xala XSLT parser allow to execute Java code. And the application features, which could add some additional URL handler. So that's the file URL handler. Under Unix, you can access pseudo file system like proc, which could be useful for exploitation of memory corruption bug later in the process. The path hash under Windows, and directory listing under Java. PHP. There is a lot of special URL handler in PHP. The HTTP one is very friendly because if you can get some error message, you can get the banner, so it's SSH, it's VNC. There is a PHP URL handler which can be used to do some preprocessing on open file. This means that you open this kind of URL, and each time you call read on the file descriptor, you will get by 64 encoded result. So this file in proc will contain some null byte every time. And using this trick, you can get the base64 version and decode it later. And you can also use SSH2 to access the local machine or some internal other machine. You only need to find a weak username and password. So I'm using Oracle. Why? I don't know. And you can use this trick to read file on other machine. And I have a demo using the local root account. So here it's very simple. We refer the self maps file in the proc pseudo file system. So under PHP, as we can see, we are in a Apache 2 process. And you get some nice information about the stack and the heap addresses, and every module loaded. If we do the same thing in Perl CGI application, we get everything related to Perl, including heap and stack address. And of course, it works just as well with the etc password. So that's for Linux. If you want to play with Windows, it's very simple. And it works. Okay, something more interesting. Here we will use the PHP handler twice. One for do some route 13 conversion, and one for base64 encoding. And we'll read to specific file, as you can see here. So it works only on PHP. So that's your LSB release file, no problem. And here we get the command line of the current process. So we have Apache 2, then a null byte, then a -k, then a null byte, then start. So it's totally impossible to read this kind of file without using the PHP trick, because it's not an ASCII file. Now we will connect to the SSH port on the local machine, and we get everything you need. So I'm using Ubuntu. And here, the local root account has a weak password, and I will try to read the etc shadow file. But it's a little longer because we need to do an additional SSH connection. And here my root password. You can take pictures. Okay. And just to show the directory listing under Java, I will request the program file folder under Windows. Question? Okay, let's go. So, I will now speak about XSLT. XSLT is, I have an introduction slide, yes. XSLT is a functional programming language, which is, the functional word is part of the program. We will see later. And it's defined by the W3C since a lot of years. And it's still misunderstood, it seems. So the purpose of this language is to transform XML document to something, which could be XML for data extraction, which could be SVG image. You can produce a chart from XML data, or PDF, TXT, whatever. It's Turing complete. There is some proof available online. So we know we can play a lot of tricks. And its main use are extracting data, either to display it to human people or to feed it to another application. And for example, under OpenOffice and probably Microsoft Office, when you convert one Office document to another format, XSLT is used behind the scene to do the conversion. And where can you find some XSLT parser? So your word processor is using XSLT, your browser is using XSLT, your database server is using XSLT. For example, in Oracle, it's very easy to trigger the XSLT parser. And in XML digital signatures, you may find some XSLT support. It depends on the implementation. That's a list of XSLT engines I played with. In green, it's parsers where I didn't find any vulnerability. In blue one, it's parsers which are safe by default, but you can easily change a configuration option to get some vulnerable state. And in red, it's vulnerable XSLT parsers. Vulnerable, it could be to design issues or memory corruption or anything else. So that's the introduction to XSLT. The fuzzing part, I have done some very stupid fuzzing on XSLT. I mean stupid, it's mutation-based fuzzing. It's very simple. You take a lot of XSLT engines. You take a lot of input files that you will find on Google or in bug trackers or in conformance verification software. And you use a diversifier, which is a tool which will take an input file and produce several output files with a small modification. And you do some kind of monitoring looking for bugs. The diversifier I use is Radamsa, which is very, very, very cool. And so I generally give it 5K files and ask for 1 billion in output. And I feed them to the parser. The monitoring was done with Valgrind if I don't have access to the source code, for example, for the Oracle XSLT engine, and done with Address Sanitizer, which is a LLVM plugin when I can recompile the parser. As for any fuzzing session, the only interesting thing is how much bug you found. So I found a lot. This is, I have very few published advisories because vendors are slow. This is Mozilla. And the interesting thing about this bug, outside of the free t-shirt, is the bug itself. In fact, I took a SVG image. I only replaced the SVG namespace by the XSLT1, and it caused a very specific code path in Firefox. Nobody was able to understand what happened, and we don't know if it's exploitable or not. Mozilla chose to play safe and say it's exploitable. But the modification, it's like copy-pasting 20 characters and you trigger a crash in Firefox. Okay, this one is interesting. So on the lower part, as you can see, this is Oracle error code for segmentation fault. And as you can see in the log, the frame pointer is controlled by the attacker. So we have a very basic Stack Overflow. And for everybody interested, that's the way to access the XML and XSLT parser in Oracle. This means that if you have a SQL injection on an Oracle database, you can very easily trigger this kind of overflow and get a shell on the database server. This is Adobe Reader 9 under Linux. It seems it's only a crash, but it occurs during the malloc consolidate, so it's heap corruption. And it's not a very nice bug. That's why I'm able to give some information before release of the patch. But I have some other bugs working very well on Adobe Reader 10 under Windows, which is the latest version, but no patch. So there is much more. There is some WebKit, Oracle, Opera, really a lot of bugs. Okay. So now we speak about basic constructs. The problem with XSLT is that it's a functional language. This means that by construction, you will not be able to create state, and you will not be able to have writable variables. So from an exploitation point of view, it's a big problem because we can't create a loop. We can't create neither for or while, and every variable is read-only. But we have some very specific objective. We want to do some brute force. So we want to have a for loop, and we want to execute commands and get the output. So we need a while loop. So brute force. It's quite simple. We will put our data for the while, for the for loop in XML, and we will use XSL for each for the processing. That's an example from the WebKit vulnerability dropping file on the local drive. In blue, it's the content of the file I want to drop, and in green, it's some possible path. And I want to try every possible path. So we get this kind of loop. You need to see the root tag is data, and then location. So we go to the root tag, and for each location, we get the value, and we try to create a file in this location with this content. So we effectively have a for loop. If you have some SQL extensions in your XSLT parser, you can use this kind of for loop in order to brute force credentials for internal database. And once you find a valid credentials, you can use the XSLT extension to grab data. And I have code brute force password cracker. It should be available online on the wiki. The while loop is much more complicated. So we want to read std out. The solution is to use some template, recursivity, and a code generator. The code generator was created by a German guy, and it will introduce 3 new tags, which are loop updates that you can use to have some writable variable, and the loop for and loop while construct. Just to show the complexity, that's a 4-line of Java who reads a line, append it to result, and at the end will print the result. It's 4-line. If we use the XSLT loop compiler, it's 18 lines. So we can see our read line here. And at the end, we will try to print, well, here we will try to print the result. But this is invalid XSLT code because you have this kind of tags which are forbidden. So you use the code generator and you get this kind of valid XSLT code which is 50 lines long, but which will work as XSLT loop. Okay, this one. So for the loop demonstration, we have a very large list of Java property, and we want to get their value. And we get a for loop here. For each property, we get its value, its name, its value, and we display everything. And it works very well. And as you can see, I'm using XP SP3 on a French computer, blah, blah, blah. And it's Java 170. For the while loop, we have an XML document with a list of commands we want to execute. And you can see the scroll bar here. We have a very long XSLT document, which only, in fact, you have some fingerprinting of the underlying operating system in order to choose between bash and cmd.exe, and then it executes the command. So it works, as you can see. There, we get the Microsoft version. We get a directory listing for the C drive, and then the output of the set command. Okay. Last part. There is several ways to gain execution of high-level code in XSLT parser, mainly PHP, .NET, and Java. For example, in Xalang by default, you can execute Java code if you can execute XSLT code. In PHP, you can execute PHP code if the register PHP function is called. And in XML Spy, which is a client-side software we use for generating or creating XML file, you can by default execute .NET or Java code. So in PHP, it's very simple. We will use this namespace that I showed at the beginning. We will associate it to the foo keyword. And then in your XLT document, you need to call foo function and then the PHP function and its arguments. So for example, calling PHP info, it's just foo function PHP info. The bad news is that require, include, and include once, and eval can't be called using this kind of stuff. I don't know why. It seems it's a PHP specificity. It's not functions. But we can use assert and prereq replace, which are well known to allow PHP code execution. Java is more complicated. In fact, at Berlin Side last year, I said that it seemed impossible to get some Java and XSLT interactive shell because we can't create thread and we can't create our own classes. So it seems very difficult. And just after Berlin Side, I published my content online. And I have a German guy, which is Michi42, who told me that I was wrong, and it was possible to execute arbitrary base64 class files in Java. So for me, it was a very big win, because it seems to be impossible for 2 or 3 months. I spent on this kind of bugs. And in fact, Michi have published Java Payload, which is a Swiss knife for Java exploit. And you can output a lot of payload in a lot of formats. For example, you can create jar file or applet, and this is interesting to me, xlng output. So you can choose your payload, which is a reverse shell, for example, and ask for xlng output, and you get an XSLT style sheet, which will trigger a reverse shell. In order to get things done easier, I code a Metasploit module, which should be perhaps in the next version, which is for .3. And for the moment, you can still access the ticket. The code is available in the ticket. And it's a very easy way to get some PHP or Java interpreter shell. And I have some demonstration. So that's the way to get a PHP interpreter shell in XSLT under PHP when PHP register function is called. So we will call prereq replace first. Here the namespace, which is associated to PHP. Here PHP function, prereq replace, and here our code, our PHP code. And our PHP code is here. It's very simple. We will do an eval on the base64 decoding of this kind of string. So the base64 string is generated automatically by Metasploit. Okay, so Metasploit, it's very simple. You use the exploit. Target 0 is for PHP. Target 1 is for Java. Okay. That's RC resource, Metasploit resource, just to avoid typing every command. So I have, I don't know if you see from the back, I have two jobs who are waiting. It's the PHP and the Java one. And if I submit to PHP, okay. Thank you. Okay. As you can see, it's a PHP interpreter shell under Apache. Okay. The Java one is much more complicated. In fact, we will use reflection in order to access enough internal function of Java to create our own classes. And we will use enough functionality to download external jar file, which include Metasploit interpreter, and we will just execute it just to show you. If somebody understands this kind of Java code, kudos. And submit to JSP. It's a little longer. Okay, test complete. And another Metapreter shell, which this time is in Java, and as you can see, I get a system privilege under the Windows machine, which is game over. Okay, and the last one. That's the smaller Firefox crash I have. As you can see, there is a right parenthesis missing here. And this will break the parser. And you can get something like that. Boom. Bye-bye. Okay. Conclusion. XML is everywhere. You really need to wonder how your application is parsing XML and not is it parsing XML. XML is much more than data. The XML external entity attacks are related to the grammar. The XSLT attacks are related to code execution. It's not data, and you need to check very carefully if your document embed more than data on how your application will parse this kind of content. Third point, the offensive side have more and more tools. In penetration testing, I gain sometimes some shells, big backend like processing credit cards using XSLT. So it works really well in real life. And the last point, which is not a good news, is that this kind of DTD and XSLT attacks are known for more than 10 years. The first publication were in 2001 by Guninsky, for example, and we still find a lot of vulnerable applications. If you have some questions, it's time, and thank you for coming.
Thank you for a nice presentation, cool stuff. Basically, a short question, where can we find, or did you publish the demo page you have been using for the presentation? Can we get the source code for that and play?
Okay, the URL was on the last slide, which was already shipped. It's, okay, thank you. So on this wiki, you will find most of my findings, including every source code and everything. The fun part is that this wiki has a REST interface for publication, and it's vulnerable to XXC attacks, which is still unpatched. So please do not hack my own wiki.
Any more questions? No? Well, then please thank him. There's a coffee break right now going on, and after that's going to be the last talk over here with the, out of my top of my head, the ghost in the window.